As you can see, this class is about fractions. Now, that may seem a little strange to you. You are aspiring to do perhaps a university course, and you're aspiring to do it in business or in a business-related area. And we're starting here with a video on fractions. That sounds a little not joined up. Well, we don't offer any apologies here. What we want to do is to make sure everyone has got the basic skills as well as an understanding of what's required later on when much more advanced skills are required. And many of you will have been to school perhaps a long time ago and a little rusty on the basics. So we offer a whole series of videos on quite fundamental parts of basic school curricula. For example, fractions. We also will do percentages and ratios and simple interest, and we will offer lots of very short classes on a lot of these very simple sounding topics. But we're going to start today with fractions. And again, as I said, no apologies. We want everyone to make sure you are completely up to speed with fractions. And we'll have more classes along similar lines later on. They're not compulsory. You may not want to see it, in which case turn it off if you are completely happy about your knowledge of fractions. So let's make a start. We're going to start with the idea of a circle. Now that's quite straightforward. A circle is a circle. Except you can have half a circle. If we were to draw a line down the center, not very well drawn, but we'd end up with half a circle. That introduces us to this concept of fractions. So this one over here is half the size of this one. And before we explore any further here, the clue is in the fraction itself. We've written a half as the fraction. Now, a half is the full one, and the full one's over here. Let me just rub out the X in the center and get rid of that. Okay, so that one refers to the full circle. And we want to divide it in half. We want to divide it into two parts. So we divide it by the 2. So the fraction is telling us what we're going to do. Okay, so let's just get rid of that. As I said, very basic, very straightforward material. And if we have two halves to a circle, as we have here, except we've separated them out, if we add the two together, if we use our add and, in a sense, pull these two together, we'd end up with the circle. So that's the basic concept. It's very, very straightforward. We're breaking a full number or a full object into parts. And in this case, we broke it into two parts, which are two halves. So the circle is equal to a half a circle plus half a circle. Now, let's consider a half of 4, which is 2. Well, we're going to meet this again in a few moments, but let me preempt it by saying that what we've got here is a half of 4. Well, when I say of 4, and I'm going to emphasize this later, of means multiply. So we're going to multiply that by 4, and we're going to get, well, if we multiply it, what we actually do is we say it's 4 over 2, 4 divided by 2, because we multiplied a 1 here by the 4. So we get 4 over 2, which of course is just equal to 2. Now, that's all we've got here. We've got a half of 4 is equal to 2. I should get rid of my scribbling before I bring up something new. Keep it tidy. Right, so when we say of, and we're talking about fractions, this is important. It means multiply. So whenever we see the word of, it means multiply. A half of 4 is 2, is the same as a half multiplied by the 4. So those two are the same. The of and the multiply are the same. So what we've got then is, as I said earlier, 4 multiplied by the 1, which is 4, and it's all over 2. And that's the 2 there, and that just gives us 2. So we've got the same thing. It's whenever we encounter the word of, it means multiply, and we've just multiplied a fraction here. In this case, we've said we've multiplied a half by 4, which gives us 2. In other words, there are 4 halves in 2. We take 4 over 2. The top part we call the numerator. In a fraction, the top part is the numerator. So always remember, the top part of a fraction is called the numerator. The bottom part is called the denominator. So the denominator comes under the line. So calculation, 1/3 of 12. Well, 1/3 of 12 is the same as 12 over 3, because we're multiplying. Of means multiply, so we're really multiplying the 12 by 1/3, which gives us the 3 as the denominator. And 12 over 3 is equal to, well, that cancels out. The 3 goes into itself, it goes in once, and it goes into 12 4 times. So 4 divided by 1, which is the same as 12 divided by 3, and that's equal to 4. So we've done some manipulation here. We found 1/3 of 12. We write it out first, 12 over 3, like we've got here. Then we say, okay, we can cancel. The 3 goes into itself once. We can divide 3 by 3. That's just 1. And we can divide 12 by 3. Well, that's just 4. 4 3s are 12. So 4 over 1 is the same as 12 over 3. 4 over 1 is just 4. So the answer is 4. So 1/3 of 12 is 4. So back to circles. Here's our circle. We've broken it into 2 parts. We could divide it into 4 parts. If we were to split one of these, let's make a split there, or a split over here, we'd have this part, this part, this part, and this part. And all of those are the same. They're all the same size. So we've got 4 equal parts. And this gives us the concept here of 1/4. So the 1/4 is this part split, the half cut in half. So it's really a half of a half, which is just, of course, as we saw earlier, half multiplied by a half, which is equal to 1/4. So let's just play with that for a moment. Let's just get rid of our scribblings again. Keep things tidy. 1 divided into 4 equal parts. Now, we're going to add fractions. We're going to add a half plus a half. And this is not rocket science, but it is very important because we can come on to bigger fractions where it's not so simple, and we need to have the principles established. So we have a half plus a half, which is equal to, add the numerators together. The numerator here is 1 plus 1, which is equal to 2. So we don't add the denominators, please note, we add the numerators. The denominators are constant. They are common, I should say. They are 2. The denominator is 2. There's 2 for each of them. So we have no problem adding here because these fractions are similar. They've got the same numerator. So we just add it's the same denominator. So we just add the numerators. 1 plus 1 equals 2. So what we've done is, if you add a half of a circle to half of a circle, we get a full circle. If you add a half plus a half, what we're doing is adding the numerators. That's the point of this slide. I'm not trying to teach you how to add half plus a half. Everybody knows what a half plus a half is. But we're establishing here, we're just concentrating on the numerator, the top part. So when we make more sophisticated fractions, as you go through your studies, you know, just add the top part, the numerators you add, providing the denominator is the same for each one. In this case, the denominator is 2, so we just add the top parts. Now, this is what I was saying earlier. We do need the denominators to be the same. And this time they're not. It's a 2 and a 3. So the denominators are different and we need to add these fractions. So what we need to do is find a common denominator. And that's the term we use. A common denominator means one that will match both of these. In other words, we can turn a half into a fraction that has 6 as a denominator. If we just imagine that we've got, let's rub out the 1. We'll just say we haven't got anything at the top. So we're going to start just with the 1. We've got 6 down here. And we're starting with a half. So a half is equal to something over 6. The way you do that is divide the 6 by the 2, which is 3, and then multiply it by the 1. So we divide 6 by 2 and multiply by 1, which is equal to 3. So 3 over 6 is the same as a half. And why 6? Well, because we can do the same for 3. It's common. We can do the same for 3. With 3, we have, we'll have 1/3. And 1/3, if we turn that into a 6, we'll just into a 6, we need to multiply that by 2. We need to multiply the 3 by 2. That means we need to multiply the 1 by 2, so it's 2 over 6. 2 over 6 is the same as 1/3. You can do it in reverse if you want. You could say, well, let's say we started with 2 over 6. Now, what I can do here is just divide the top part by 2. That gives me 1. Divide the bottom part by 2. That gives me 3. So 2 over 6 is 1/3. Right, let's clear it all off and go and see what the slide has to say about it. So we've got a half plus 1/3, and we've got this common denominator of 6. So we've put 6 underneath, and we've put 3 and 2 on the top, because we're adding the two parts together, the two fractions together. 3 plus 2 is 5, so 5, 6. In other words, a half plus 1/3 is equal to 5 over 6. Now, adding fractions, an example. Well, let's say we wanted to add a quarter, 1/4, plus 1/5. I want to find out what that's all about. Well, the common denominator is 20. We get that by simply multiplying 5 times 4, 20. So we know, since we multiply them by 4, 4 will divide into 20 and 5 will divide into 20. So in this case, if you divide the 4 into 20, you get 5. And 5 times 1 is 5. So what we do is we divide that 4 into 20, which gives us 5. And then we multiply the 5 by the 1, and that all gives us 5 over 20, this one here. Right, let's tidy up. Now, we've got 5 over 4. Now, this one here, the 5 one, well, divide 5 into 20, get 4. 4 multiplied by 1 is 4. So the common denominator is 20. We make everything 20 in the denominators along here. Everything's 20. Divide 5 into 20 is 4. 4 times 1 is 4. And that's the answer. Now, when you add 5 plus 4, you get 9. So 9 over 20 is the overall answer. In other words, a quarter plus 1/5 equals 9 over 20. That's adding fractions. One more. A half plus 1/3 plus 1/5. Now sometimes finding the common denominator can be quite tricky, so we may have a problem finding the common denominator. It might mean a very big number, or it might mean a big number. Actually, we could reduce it, we could make it smaller, but the easiest way to go about it at the moment is just simply find something that all of those will divide into. Well, the most obvious candidate is 2 multiplied by 3 multiplied by 5, because we know 2 will divide into it, 3 will divide into it, and 5 will divide into it. So the common denominator is 30. That's 2 times 3 times 5, which is equal to 30. Now, 2 into 30, this one here, 2 into 30 is 15. 3 into 30 is 10. 5 into 30 is 6. So all of them are over 30. That's the common denominator. And if we add 15 plus 10 plus 6, we get 31. And 31 divided by 30, well, there's 1/30 in there, so it's 1 and 1/30. 30 goes into 31, goes in once, and 1 over, the 1 over is 1/30. So that's the answer. Right. Another example. 4, a quarter, I should say, plus 1/10 plus a half is equal to what? Well, the common denominator is 20. Well, we could say the common denominator was 4 times 10 times 2, which would be 80. That would be true. It's just, it's too big. We can do it smaller. We can be more efficient. So if you've got 80, let's think of half of 80, 40. Does everything divide into 40? Yes, it does. Half 40, well, 20. Everything divides into 20. Yeah, 4 divides into 20, 10, 2. How about 10? No. The 10 divides into 10 and the 2 divides into 10, but the 4 doesn't. The 4 goes in 2.5 times. That's no good to us. So the smallest common denominator, which is what we're after, the smallest one, is 20. So we just have to, when we first set out, we could, you could use 80, it's just not very efficient. You just have to reduce it at the end. It also doesn't look good. The best way to do it is start just multiply everything. 4 times 10 is 40 plus 2, times 2 I should say, is 80. Well, can we make it smaller? 80, 40, yeah, 40 would work. 20, yeah, 20 would work. 10, no. 12, no. So that's it, it's 20. Now, 4 into 20 is 5, so that's where we get our 5 from. 10 into 20 is 2, so we get that. 2 into 20 is 10. So add 5 plus 2 plus 10 and we get 17, and it's 17 over 20. That's the answer. Now simplification, fractions simplification. Well, this means writing the fraction with the smallest denominator. I've already hinted at this in the previous slide. So if you take 2 plus 3 plus 5, 2 plus 3 plus 5, well, 30 works, but does 20? No, because we can't divide by 3. 3 doesn't go into 20, it goes in 3 sixes are 18, 3 sevens is 21, so 3 rules it out. 15, no, 2 won't go. Goes in 7.5 times. So what we do then is 5 3 is 15, 15 times 2 is 30. So the common denominator is 30. Now, 2 into 30 is 15, 3 into 30 is 10, so it's 10 times 1, please note. So multiplying by the numerator up here. So 3 into 30 is 10, 10 times 1, so that's times 10, which gives us 10. 5 into 30 is 6, and it's 6 times 1, which is 6. Now add it all up. 15 plus 10 is 25, plus 6 is 31. 31, 1/30th, which is what we had before. It's exactly the same calculation, except now we're a bit more familiar with this idea of getting the smallest denominator. Now it means, simplification means writing the fraction with the smallest denominator. 4, 10 and 2 as denominators. Well, we could do 80, as I said to you before. This is an example from the previous slides. So by multiplying 4, so it would be 4 times 10 times 2, that's just 80. So that's our common denominator. But as I said to you earlier, when we met this problem earlier, we can be far more efficient in doing it. And this is it again, just to drive it home. So we'll take this as our common denominator and we put it down here. So 80 goes on underneath. Now 4 into 80 is 20. So it's 20 times 1. So we're multiplying it by the 1 here, I should say. So it doesn't change. 4 into 80 is 20. 20 times 1 is 20. 10 into 80 is 8. 8 times 1 is just 8. 2 into 80 is 40. 40 times 1 is 40. So now, this is the way our fraction looks like. Add it all up, we get 68. 20 plus 8 is 28, and 40 is 68. So it's 68 over 80. Well, whenever you see a fraction like this, we can divide it by 2 because it's even. 68 over 80, that's even. Even means we can divide it by 2. So if we divide it by 2, we get 2 into 6 is 3, 2 into 8 is 4. And we'll leave the 80 for the moment. So, well, let's divide it out. So 40. We could have left it and played around with the others and come back and do the denominators. It's always best to do it all in one. So I think no, I don't recommend what I was saying. So here we've got 68 over 80, which is 34 over 40. But again, you see, look, this 34 over 40, we can play with that. Because again, it's an even. 34 is even, and 40 is even. So we could divide that by 2, which gives us 17, and divide this one by 2, which gives us 20. So now we write down 34 over 40 is the same as 17 over 20. Can we go again? Well, no, we can't, because 17 is an odd number. So we can't do anything with that. We have to leave it. 17 over 20 is the best we can do. And that's the smallest denominator we can have. The 20 is the smallest denominator. Now I should take away some of my scribblings. So 17, just to emphasize it, 17 over 20 is the same as 68 over 80. So this one is the same as this one. Just take away those. And what we've got is the smallest denominator. The smallest denominator being 20. Now subtracting fractions. Well, let's say we have a half, take away 1/3. Again, we need common denominator. So we find the common denominator, in this case 6, 2 times 3. So a half, if you turn a half into 6, we multiply the denominator by 3, multiply that by 3, and you're going to have to multiply this by 3. And 3 1s are just 3, and 3 2s are 6. So 3 over 6 is the same as a half. So that's the half done. Now we do the same for the 1/3. 1/3, we multiply the bottom part by 2, which gives us the 6. And we have to multiply the top part by the 2. Whatever we do to the bottom, we must do the same to the top to keep the same fraction. So 1 times 2 is 2. In other words, 2 over 6. So we've turned a half and 1/3 into 3 over 6 and 2 over 6. So we can now rewrite it. Let's take this out. We can rewrite it now as a half minus 1/3, which is our original here. Half minus 1/3 is the same as 3/6 minus 2/6. Well, leave the denominators alone. Subtract 2 from 3 is 1. So the answer is 1/6. And that's how we subtract fractions. Now, multiplication of fractions. Well, what is half of a half? And I've talked about this really at the start a little more. So if we have a full circle and we have half a circle and we take half of the half, we take a quarter. A half of the half of means multiply. So we're really multiplying the half by a half. I'm going to come on to this in a second, but let's just preempt it here. We have a half of a half. Multiply the numerators together. 1 times 1 is 1. Multiply the denominators together. 2 times 2 is a quarter. So a half of a half is a half multiplied by a half, which is a quarter. So half of a half is equal to a quarter. A half multiplied by a half is a quarter. So whenever we see of, it's multiply. Sometimes you just see it multiply it, in which case you multiply the numerators together, multiply the denominators together. So what is 1/7 of 2/3? Well, 1/7 of 2/3 is 1/7 multiplied by 2/3. That means 1 times 2 and 7 times 3. So the answer is 2/21. 1/5 of 1/5. In other words, what is 1/5 squared? Whenever we multiply a number by itself, we can call it squared. So 2 times 2 is 2 squared. Half of a half is a half multiplied by a half, which is a half. Sorry, 1/5 of 1/5 is 1/5 multiplied by 1/5, which is 1/5 squared, which is 1/25. We simply multiply the numerators and the denominators, and that gives you there, and that gives you there. Four multiplied by 2/9. Well, here we've got 2/9 4 times. So we've got 2/9 times 2/9 times 2/9 times 2/9. It's the same as multiplying. It's the same as adding. We're adding 2/9 4 times. So if we add 2/9 4 times, which is the multiply by 4, we've got 2, 4, 6, 8. And that gives us 8. The numerators add up to 8. We leave the denominators because we're adding. So the answer is 8/9. 2/9 plus 2/9 plus 2/9 plus 2/9 is equal to 8/9. We could do that simply over here, and I'll mention this again. We could just simply say 4 times 2. So we'd have 2/9 multiplied by 4, which is equal to 8/9. We multiply those together. But strictly, I suppose we're just adding the thing 4 times. We're adding 2/9 together 4 times. Now this one's slightly more complex. We've got 2 times 1/9 times 3/7. So we can do it any particular way we want. We can work from the start to the end, or from the end back to the start. It doesn't matter. But it's all multiplied, so it all becomes one number. So we've got in the end 2 times 1. Well, that goes there. Sorry, overshot slightly, but it goes here. 2/9. And this one here we've left, this is the same, 3/7. So we got rid of the 2 by multiplying 1/9 by 2, which gives us 2/9. So that one there. Now, if you multiply the numerators together, you got 3 times 2, which is equal to 6, and 7 times 9, which is equal to 63. So the answer is 6/63. Now you can't reduce that. There's nothing we can divide into it to make it smaller. It's just 6/63. Later on, when we look at percentages, you can divide it out and turn it into a percentage, which is always over 100. Now, division of fractions. What is 12 multiplied by 1/3 multiplied by 1/7? It's not a division really, is it? So here we've got, it's another example of multiplication. Here we've got 12 multiplied by 1/3 multiplied by 1/7. Okay, so this time we could take these two together. So we got 1 times 1, which is this number over here. And we got 7 times 3, which is 21. So this time it's 1 over 21 times 12. We left the 12 alone. Now multiply 12 by 1 over 21, and we simply get 12 over 21. The 12 multiplies by the 1, which gives us the 12. Now here we're asked to simplify 12 over 21. Well, when you're given a fraction like this, we should always look to see if we can make it smaller. It's easier to handle. So is there anything that divides into 12 and into 21? So just think about mental arithmetic. Anything divides into 12? Divides, well, 2 doesn't. 21, that's no good. 3? Yeah, 3 does. 3 into 12 is 4. 3 into 21 is 7. Are there any more? 4? No, it's even. 5? Nope. 6? No. 7? No. So go with 3 and see what happens. So divide 12 by 3, which gives us 4. If we look here on the right hand side, over here we've got it. 12 divided by 3 is equal to 4. 21 divided by 3 is 7. So 4/7 here is the same as 12 over 21. Now division of fractions. For example, what is a half divided by, what is 1 divided by a half? This may be written as follows. How many halves in 1? Well, if we think about that, there are 2 halves in 1. If we have 1 cake and we divide it into 2 halves, how many halves in that cake? Well, there are 2. We just cut it in half. There are 2 halves. So 1 divided by a half, we know, is 2. There are 2 halves in 1. So we know that there are 2 halves in 1. So 1 divided by a half is equal to 2. There are 2 halves in 1. A half plus a half is equal to 1. So there are 2 halves in 1. So what is 1 divided by 1/3? Well, in similar fashion to the halves, there are 3 1/3 in 1. We could break up something into 3 parts. We know that there are 3 parts in 1. We can divide up 1 into 3 equal parts. If we have a cake, imagine a cake, we can cut it into 3 equal parts. There are 3 of us who want to share this cake. We can cut it into 3 equal parts. So there are 3 1/3 in 1. So 1 divided by 1/3 is 3. There are 3 1/3 in 1. 1/3 plus 1/3 plus 1/3 is equal to 1. So what we know so far, and there is a pattern here, we know that 1 divided by a half is 2. 1 divided by 1/3 is 3. And hopefully you'll notice now, when we divide by a number like this, there are 2 halves in 1. So that goes up there and that goes there. So when we divide by 1/3, we just simply get the 3. In general, and we do this a lot when we study mathematics, we like to use n. We just n because it's any number, just a number. So we say 1 divided by some fraction, and we don't know what the denominator of the fraction is. Here the denominator is 3, and here the denominator is 2. But n could be any number. It could be 227. That's quite a random number, I just picked it, but it could be any number. If it is 227, then when we divide 1 by 1 over 227, this will be 227. Because we do it by what's called induction. We keep doing this, process here for lots and lots and lots of fractions. And after a while, we say, well, look, it works every time. So if we have 1 divided by 1 over n, it's going to be n. So we can pick any number. 1 over 227 is equal to 227. We just deal with this one. We do that by induction, because every time we do this calculation, we find the same process. We find the same way of doing it. So after a while, we generalize it. And we generalize it and we say, that's it. So when dividing by a fraction, we say we invert the divisor, the number underneath, the denominator. We invert the divisor and multiply. Invert means turn it upside down. The divisor is the denominator. And here we've got it. So we invert the divisor. The divisor here is a half. That's the divisor. That's the divisor. So what we do is we invert it. We turn it upside down. So we've got 1 and it's 2 over 1 and multiply. So we multiply that and that just gives us 2. So we invert the divisor and we multiply. Just move up my previous one. So 1 over 1/3 is 3 and 1 over 1/n is n. Whatever the number n is, we'll just give it a number. That's the value of our fraction. When we divide 1 by that fraction, we get the number. The rule is invert the divisor and multiply. So remember that. When you're dividing fractions, invert the divisor and multiply. The divisor is the denominator, invert it, turn it upside down, and multiply. 1 divided by a half is equal to 1 multiplied by 2 over 1. The 2 over 1 is when we invert a half. Invert the half, turn it upside down, and multiply. And we get 2. Invert the divisor, which is a half, so it becomes 2. And multiply by the numerator, which is 1. 1 divided by a half is 2. 3 divided by a quarter is 12. There are 12 quarters in 3. There's 4 quarters in 1, so there must be 12 quarters in 3. But if we apply our rule, we just simply say we invert the divisor. Here is the divisor. We invert it, so we turn it upside down, and we multiply by 3. When you turn it upside down, you simply get 4. Becomes the 4. That's the 3. Multiply it, and you get 12. 1/7 divided by 2/7. It's the same thing. It's exactly the same process. Our number here is 1/7, so we write that down. There it is there. 1/7. This is our divisor. We invert it, we turn it upside down, and we multiply. So when you turn 2 over 7 upside down, you get 7 over 2, and you multiply. So now we got 1 times 7, this plus this is 7, and 2 times 7 is that. And 7 over 14, well, you can reduce that, you can make it smaller, because we know 7 goes into 7 once, and 7 goes into 14 twice. So the answer is a half. 1/7 divided by 2/7 is actually a half. The next one is multiplication and division must be done before addition and subtraction. Now this rule must be followed. This is for just general numbers. So here we have 2 multiplied by 4, take away 3. So what we do here is the rule is multiplication and division must be done before addition and subtraction. So This is multiplication, this is subtraction. So we must do this multiplication first. In other words, we have 2 times 4, take away 3. 2 times 4 is 8, take away 3, which is 5. And that's our answer, 5. We only get that because we follow the rule. Multiplication and division must be done before addition and subtraction. We must not do this. We must not write the same thing down, 2 multiplied by 4 take away 3, and then go ahead and say 2 multiplied by 4 take away 3. 4 take away 3 is 1. 1 times 2 is 2. And that is wrong. The rule is we must do the multiplication and division before addition and subtraction. That's a rule to remember. So what we've got down there is wrong. That's all we're going to deal with. So let's leave it at that and say thank you for watching.